Okay, so we're going to have a look at a large displacement analysis with Apex. So by default we've got the linear solver, so we're going to show a couple of utilities to set this up for NonLinear Solve. So we've got here a curved plate simply supported at both ends, with the caveat that one edge has got a tension load on it. Okay, so we're going to run this as a linear model first of all. So just place that in the analysis scene, solve using the linear solver, and then show how the stiffness matrix and displacements are calculated for this linear case. Okay, so going to post-processing, switching the deformed shape to true scale. So deformed off, deformed on. So it's basically saying as the tension load is applied, no membrane stiffness is considered, and the vertical displacement is just amplified based on a linear stiffness matrix calculation. So if we to animate that, you can see that's what the linear solve is going to tell us, and that's clearly not appropriate for this type of structure. Okay, so we're going to set up a large displacement run now. So back into the model, I'm going to create a second scenario, place that in the analysis scene. So we go into studies, so we've got our, just repeat that, go into our studies that we are, generate our scenario. So we've now got two scenarios. First is the linear run, the second we're going to set up for the nonlinear large displacement run. So we go into our utilities, interoperability, export utilities, and in here we can specify the solver types. This is Nastran Solve 400 run we're going to use. We're going to export to our BDF file, so just call that LGDisp for large displacement. Check on our miscellaneous settings we've got large displacements turned on, and then just hit the tick button. Okay, look into our go into our workspace. We can delete the original file. So in terms of our Solve 400 run, key things are we've got Solve 400 call here, we've got large displacements turned on, and then we can see our nonlinear stepping algorithm that's set up to do an incremental solve and recalculate the stiffness matrix through the solution. Okay, so go into Nastran, run the Nastran job, LGDisp. So as we're running, we can see the generated files, so the status file we can open up, and we can see the solve, the incremental solve as it runs through to full load. We've got the job exiting with a 0 indicating it's terminated normally, or correctly rather. So we go back into Apex, and at this level now we can import the Solve 400 results. We can browse it to the H5 file and bring that in. Just accept the messages, and then we can post-process. Okay, so we're going to see two windows now. The window on the left is the linear displacement. The window on the right is the nonlinear displacement. So just orienting those in the same manner, and then switching that through to true scale. Just make sure we've selected the appropriate step for the nonlinear run. There we are. Okay. True scale, that's it. Right, so on the left we've got the linear displacement with that horseshoeing effect because the membrane stiffness is not calculated. Okay. And then on the right, again, true scale displacement. If we animate this, we can see how the membrane stiffness is calculated. Okay, indicating that the large displacement run is completed successfully, and we've got the true effect that we want to see. Of course, we can run this for more complex problems such as post-buckling, that type of thing, but just to get you started with a simple example here.
I hope you found this interesting. If you'd like to develop your Apex usage, head over to our site where you'll find many online learning opportunities.